Hello students, this is lecture number 4 and in this lecture we will study what means the exact differential equation and how to find its solution. So firstly we will see the definition for the exact differential equation. So any differential equation, if it can be derived from its solution directly by only differentiating, then we say that it is an exact differential equation. Exact differential equation. Now we will see the necessary condition for exactness of differential equation. Okay, so I will repeat it again. What means exact differential equation? So exact differential equation is any differential equation which can be derived from its solution. Okay, this word is important. If there is any differential equation which can be directly derived from its solution, directly just in differentiating, then we will say that it is an exact differential equation. Okay, now this is very important. That is the necessary condition for the exactness of any differential equation. Okay, suppose we have a differential equation m dx plus n dy equal to 0, where this m and n are functions of x and y. Then the differential equation, the given differential equation m dx plus n dy equal to 0 is said to be exact if and only if it is satisfying this condition, and the condition is dabba m by dabba y equal to dabba n by dabba x. Now dabba m by dabba y is the partial derivative of m with respect to y, and dabba n by dabba x is again the partial derivative of n with respect to x. Okay, if you have the differential equation like m dx plus n dy equal to 0, and if that differential equation is satisfying this condition, that is if both the derivatives are equal, then we will say that this differential equation m dx plus n dy equal to 0 is an exact differential equation. Okay, now once the differential equation is exact, okay, if the differential equation m dx plus n dy equal to 0 is an exact differential equation, it is exact if it satisfies the condition. If it is an exact differential equation, okay, then we can directly find its solution. Then its solution is given by, how the solution will be given? The solution will be like integration m dx plus integration. Now here see the terms, here will be the terms not containing x into dy equal to constant. Here the x will be variable and y will be constant. Okay, and here will be the terms in n, not containing x. Okay, so here those terms will be free from x, so I will say this as free from x, free x. Okay, so what we will do, firstly we will have the differential equation like m dx plus n dy equal to 0. Okay, and we will prove that it is an exact differential equation. Now how we will prove it is exact? If this differential equation is satisfying this condition, dabba m by dabba y equal to dabba n by dabba x. Okay, if this is happening, then the differential equation will be an exact differential equation. Then we can directly find its solution using this equation. Okay, and see this equation, what this equation contains. It is integration of m dx plus integration of terms in n not containing x into dy equal to constant. So this is how we will see, or we will solve the examples over this topic. Okay, now we'll see the first example. The first example is solve means to find the solution. Okay, so we will check whether this differential equation is exact or not. Okay, so means what, we need to check the condition for the exactness of the differential equation. So to check the condition, firstly we will compare this to our standard differential equation m dx plus n dy equal to 0. Okay, if we will compare both the equations, what we will get? We will get the value for m is x plus y minus 2, and value for n will be x minus y plus 4. Okay, now we will check for the condition. Okay, and the condition is what? Dabba m by dabba y should be equal to dabba n by dabba x. So firstly find out derivative of m with respect to y. Okay, you are finding partial derivative of m with respect to y, means the terms of x will be constants. Okay, so the derivative of x will be with respect to y 0, derivative of y will be with respect to y 1, and derivative of minus 2 with respect to y will be 0. So our answer will be 1. Similarly, we will find dabba n by dabba x, means find its derivative with respect to x. So derivative of x with respect to x will be 1, derivative of minus y with respect to x will be 0, then derivative of 4 with respect to x will be 0. So again we get the value for dabba n by dabba x, and that is equal to 1. So from this equation and from this term, okay, what we see, what we get? We get what? Dabba m by dabba y equal to dabba n by dabba x. Okay, now this is happening because both the terms having values equal to 1, means what? The conditions are satisfying, means what? The given differential equation, this is our given differential equation. This differential equation is now an exact differential equation. Okay, now once the differential equation is an exact differential equation, we will say here the given differential equation is an exact differential equation. Okay, now once the differential equation is an exact differential equation, we can find its solution. How the solution will be given by and its solution will be given by, how the solution will be given? Integration m dx plus integration, here what will be here? Terms in n not containing x, terms in n not containing x dy is equal to constant. Okay, now we will see what this actually means. Okay, so okay, for this now you know the value for m. So in the first term, means what? Here we will directly put the value for m. Okay, so this will be equal to integration m. What is m? M is x plus y minus 2 dx plus integration. Now see this in this term, terms in n not containing x. So what is n? N is this. Okay, so we need to get the values in n, functions of x and y in n, which does not contain the term x. Okay, so if you'll see in the first term, you can clearly see x is there, so we will not take it. In the second term, only minus y is there, so we will take this as minus y. In fourth term, the constant is there, so we'll take the constant as 4. Okay, into dy equal to constant. Now take integration. Okay, so what will be integration? This implies, now we need to take its integration. Okay, first term's integration with respect to x. So integration of x with respect to x will be x square by 2. Okay, integration of y with respect to x will be x into y, and integration of 2 with respect to x will be minus 2x. Okay, plus integration of, now we need to take the integration of this minus y plus 4 with respect to y. So integration of minus y with respect to y will be minus y square by 2. Integration of plus 4 with respect to y will be 4y is equal to constant. Okay, so we will rewrite this, our final solution. Okay, so what we get finally, this will be x square by 2 plus xy minus 2x minus y square by 2 plus 4y equal to C. We can again simplify this equation by multiplying whole equation by 2. So what we will get, this will be x square plus 2xy minus 4x minus y square plus 8y is equal to constant, that will be 2 into c. I will say this as another constant, suppose c dash, and that is our final solution. So examples over these topics are very simple. You just need to check whether this given differential equation is exact or not by using the given condition, and once the differential equation is exact, you can get the solution directly. Okay, we will see for it for the next example. Okay, so next example is dy by dx equal to tan y minus 2xy minus y upon x square minus x tan inverse of y tan square y plus sec square y. Okay, so firstly we will write it in our standard form. Our standard form is what? M dx plus n dy equal to 0. Okay, so try and convert it to the standard form. Okay, take this term to the LHS. Okay, and take this term to the RHS. Okay, see what will happen. Okay, this will be like x square minus x tan square y plus sec square y dy is equal to tan y minus 2xy minus y dx. Okay, I can rewrite this equation as tan y minus 2xy minus y dx minus x square minus x tan square y plus sec square y dy equal to 0. So this is our differential equation in standard form. Okay, now where the value for m, what is m? M is tan y. Okay, m is tan y minus 2xy minus y, and what is n? N will be minus x square minus x tan square y plus sec square y. Okay, now to check the exactness of the differential equation, okay, what we do, we find the value for dabba m by dabba y and dabba n by dabba x. So firstly we will find what is dabba m by dabba y, means differentiate this m with respect to y. So derivative of tan y with respect to y will be sec square y, and derivative of minus 2xy with respect to y will be minus 2x, then derivative of minus y with respect to y will be minus 1. Okay, now we will see what is value for dabba n by dabba x. Okay, now this minus sign is outside, so the derivative of x square with respect to x will be 2x minus derivative of x into tan square y. Now tan square y will be constant, so derivative of x will be 1. So what remains? Tan square y plus derivative of sec square y with respect to x will be 0. Okay, now this is nothing but minus 2x minus minus plus tan square y. Okay, now minus 2x, I will write this tan square y as sec square y minus 1. Okay, so if you'll observe, or both the equations, okay, means this equation, okay, and this equation, both are same. What I have done here, I have replaced this tan square y by sec square y minus 1. okay, by one of the identity. What is that identity? We know what 1 plus tan square y is nothing but sec square y. Okay, so I got this value for tan square y. So if you'll observe, dabba m by dabba y is nothing but dabba n by dabba x. Okay, so what we get? We get dabba m by dabba y equal to dabba n by dabba x. Okay, so once you will get this condition is satisfied, then you can directly find its solution just by using the formula. Okay, and what is the formula? For that I will take this differential equation to the next page. Okay, okay, so this is our differential equation. So to find the solution for this, what will be solution? The solution for this differential equation will be integration m dx plus integration terms in n what not containing x, terms in n not containing the terms of x. Okay, dx means what? We don't need the term which has the variable x. Okay, that's it. So we'll put the value. So this will be integration. What is m? M is tan y minus 2xy minus y dx plus integration. Now this one, terms in n not containing x. Okay, so first term contains x, so we will not take it. Second term contains x, so we will not take it. Okay, third term does not contain x, so we will take it, but also with this minus sign. Okay, so this will be minus sec square y dy equal to constant. Okay, now we have to take its integration with respect to x, means all the terms of y will be constant. Okay, so this tan y will be constant, so what remains here? Integration dx minus, we have to take the integration of this 2xy with respect to x, so what will be constant? 2y will be constant, so integration will be only of x dx minus integration of sec square y dy equal to constant. Okay, now finally we will get this as tan y, integration of dx with respect to x will be x minus 2y, integration of x with respect to x will be x square by 2. Okay, minus integration of sec square y with respect to y will be tan y equal to constant. So finally these two will get cancelled. Okay, what remains? Our final solution. What is final solution? X into tan y minus x square y minus tan y equal to constant. So this is the final solution for the given differential equation. Okay, so again that was very easy example. We'll see the next one. Okay, now the next example, again the example directly in the standard form. So directly we will see what are the values for m and what are the values for n. So comparing it with m dx plus n dy equal to 0. So from this what we will get? We will get the value for m. Okay, and value for m is nothing but e to the power x plus 2x y square plus y cube. Okay, and value for n is nothing but a to the power y plus 2x square y plus 3xy square. Okay, now check for the condition. So we will check, we will see what is the value for dabba m by dabba y, means what? Differentiate m with respect to y. So derivative of e raised to x with respect to y will be 0 plus now derivative of 2xy square with respect to y. Okay, now 2 and x are constant and derivative of y square will be 2y. Okay, plus derivative of y cube will be 3y square. Okay, so this is equal to 4xy plus 3y square. Okay, similar way we can calculate the value for dabba n by dabba x. Okay, now the derivative of n with respect to x. So a raised to y does not contain any term of x, so it will be constant. So its derivative will be 0 plus again 2x square y, its derivative with respect to y, with respect to x. So 2 and y will be constant, and derivative of x square is 2x. Also the derivative of 3xy square with respect to x, that will be 3 and y square will be constant, and derivative of x is 1. Okay, so finally we get this as 4xy plus 3y square. If you will observe, dabba m by dabba y value and dabba n by dabba x value both are equal. Okay, therefore what is happening here? Dabba m by dabba y is nothing but dabba n by dabba x. What it means? It means that the given differential equation is what? Is an exact differential equation. Okay, now once the differential equation is an exact differential equation, we can find its solution by integration m dx, integration terms in n what not containing x dy equal to constant. So put the value for m is e to the power x plus 2xy square plus y cube dx plus integration terms in n not containing x. So if you observe here, in n, okay, this is the first term which does not contain x, so we will take this term as a to the power y. Okay, second term contains x, so we will not take it. Third term also contains x, so we will not take it. So this will be into dy equal to constant. So finally we will get the solution. The integration of e to the power x with respect to x will be e raised to x, okay, plus integration of 2xy square with respect to x. Now here 2y square is constant, so what remains? Only integration of x dx plus again integration of y cube with respect to x. So y cube is constant itself, so integration of dx remains, okay, and integration of a to the power y with respect to y, that is what? A to the power y upon log a, okay, equal to constant. We have seen how to get the integration, what are the standard integration of the standard functions in the integrated part. Okay, so there should not be any problem. Okay, so this will be e raised to x plus 2y square, integration of x is x square by 2 plus y cube into integration of dx is x plus a to the power y upon log a equal to constant, and in the final step you can cancel this 2 with this 2 and that will be the final answer. Okay, we will see the next example. Okay, in the next example we again need to solve the given differential equation using the exactness condition. Okay, now already this differential equation is in the standard form. What is standard form? M dx plus n dy equal to 0. So again we will see what is value for m. M is what? Y cube sec square x, okay, and n, what is n? 3y square tan x minus sec square y. Okay, so again we will check what is value for dabba m by dabba y. Okay, means differentiate this m with respect to y. So obviously sec square x will be constant, and derivative of y cube is what? 3y square. Okay, also we will see what is value for dabba n by dabba x. Okay, so x term is only tan x, means 3y square will be constant, so we will write it as it is 3y square, and derivative of this tan x with respect to x is sec square x. Okay, and derivative of this sec square y with respect to x will be 0 because it is constant. Okay, now again if you observe dabba m by dabba y, okay, dabba m by dabba y, okay, and dabba n by dabba x, okay, this term both are equal. Okay, so what we get? We get this as dabba m by dabba y equal to dabba n by dabba x. What this implies? The given differential equation is an exact differential equation. Okay, now once it is an exact differential equation, we can find its solution by finding integration m dx plus integration terms in n terms in n what not containing x dy equal to constant. Okay, so put the values. What you will get, this will be integration m is y cube sec square x dx plus integration terms in n not containing x. So this term contains x and this term does not contain x. So what we will take, only minus sec square y dy equal to constant. Okay, now we need to integrate this first term with respect to x. So y cube will be constant. So we need to take the integration of only sec square x dx, and this will be minus integration sec square y dy equal to constant. Okay, so y cube is constant and integration of sec square x is nothing but tan x minus integration of sec square y is nothing but tan y is equal to constant, and that is our final solution. Okay, now we have again one more example over this. Okay, so again compare with the standard one, m dx plus n dy equal to 0. So comparing, what you will see, the value for m is what, 2xy plus y minus tan y. Okay, what is n is x square minus x tan square y plus sec square y. Okay, now again find out what are the different values. What is the value for dabba m by dabba y? Okay, means its derivative with respect to y. Okay, so 2x will be constant and derivative of y will be 1. Okay, plus derivative of y with respect to y is 1 and derivative of tan y with respect to y will be sec square y. Okay, again find out dabba n by dabba x. Okay, so its derivative with respect to x will be 2x. Okay, and derivative of minus x tan square y with respect to x. So tan square y is constant, so keep it as it is, and derivative of x is 1. Okay, and derivative of sec square y with respect to x will be 0. Okay, so this is nothing but 2x minus, I can write this tan square y as sec square y minus 1. So finally what we will see, 2x minus sec square y plus 1. So again you can observe here what we see implies what, dabba m by dabba y equal to dabba n by dabba x. What this implies, the differential equation is an exact differential equation. Okay, now once it is an exact differential equation, we can find its solution by finding integration m dx plus integration what, terms in n not containing x. Okay, dy equal to constant. Now put values. What is m is 2xy plus y minus tan y dx plus terms in n not containing x. Okay, so this term contain x, this term also contain x, this term does not contain x. So okay, this will be only sec square y dy equal to constant. So finally here the integration of x will be, 2y is constant, so integration of x will be x square by 2 plus y is constant, so integration of dx will be x minus, and integration of tan y with respect to x will be, tan y will be constant, so integration of dx will be x plus integration of sec square y with respect to y will be tan y equal to constant. Finally you can cancel out this 2 and that will be your final solution. Okay, again we will see one more example over exact differential equation. Okay, so again comparing with m dx plus n dy equal to 0. So what we see the value for m is what, x square plus y square minus a square, and n is nothing but x square minus y square minus b square. Okay, this is plus. Okay, now find out what are the different values for, dabba m by dabba y and dabba n by dabba x. So differentiate m with respect to y, so derivative of x square with respect to y will be 0. derivative of y square with respect to y will be 2y, and derivative of minus a square, a is constant, so a square will be constant, so its derivative will be 0. So what we get? Only 2y. Okay, similarly we can find dabba n by dabba x, so its derivative, x square derivative with respect to y will be 0. Derivative of minus y square, we are finding derivative with respect to x, right? So derivative of x square with respect to x will be 2x, and derivative of minus y square with respect to x will be 0, and derivative of minus b square with respect to x will be 0. Okay, so you can see dabba m by dabba y is not equal to dabba n by dabba x. Okay, so it is not exact differential equation. Okay, so it is not exact differential equation means what? We need to convert it to the exact differential equation, then we will find its solution. Okay, but for the instant we will only comment over this differential equation is what? This is not exact differential equation, so we cannot find its solution directly. Okay, suppose we will see this one more example, okay, to find the solution for this differential equation. Okay, so again comparing this with our standard differential equation, m dx plus n dy equal to 0. Okay, so again see what is m. M is e to the power y plus 1 into cos x. Okay, I can write this, I can take this cos x inside the bracket. Okay, or if you will not take it, then also it is fine, you can directly find its derivative. What is n? N is e to the power y into sin x. Okay, so this will be dabba m by dabba y. So differentiate this term with respect to y. Now cos x is constant and it is multiplied to whole bracket, so that will be as it is. Just find out derivative of e raised to y with respect to y, that is what? E raised to y, and derivative of 1 with respect to y is 0. So finally what we get? Cos x into e raised to y. Also we can find this dabba n by dabba x, means derivative of n with respect to x, so e raised to y will be constant, and derivative of sin x is nothing but cos x. Okay, so you can again see here what is happening. Dabba m by dabba y is nothing but dabba n by dabba x. What this implies? This implies the given differential equation is what? An exact differential equation. Okay, now once it is an exact differential equation, you can find its solution by just taking the integration m dx plus integration terms in n not containing x. Okay, dy equal to constant. Okay, so this will be like integration. What is m? M is e to the power y plus 1 dx plus integration terms in n not containing x. So n contains only one term, also contains the terms of x, so we will not take anything, so this will be 0, dy equal to constant. Okay, now integration of this e to the power y with respect to x, e to the power y is constant, and integration of dx is x plus integration of 1 with respect to x is again x is equal to c. So I can take this x out, so what remains? E to the power y plus 1 equal to constant. So that is our final solution. Okay, now we will see this example, okay, to check whether this is exact or not, and if it is exact, then we will find the solution for it. Okay, now again comparing this differential equation with the exact with our standard differential equation, m dx plus n dy equal to 0. Okay, where this m is what? X square minus 4xy plus 2y cube. Okay, and what is n? N is nothing but y cube minus 2x square minus 6xy square. Okay, so find out what is dabba m by dabba y. Okay, so its derivative with respect to y will be 0, and its derivative with respect to y will be minus 4x is constant, so keep it as it is. Derivative of y with respect to y is 1. Okay, and derivative of 2y cube with respect to y will be 6y square. Okay, also the dabba n by dabba x, so derivative of y cube with respect to x will be 0, derivative of minus 2x square with respect to x will be minus 4x, and minus derivative of 6xy square with respect to x. Okay, so y square will be constant. Okay, and derivative of 6x with respect to x will be 6. Okay, so what we see here, minus 4x minus 6y square. And if you'll again observe, okay, this term and this term both are equal. Okay, so finally we can say here as dabba m by dabba y equal to dabba n by dabba x. This implies the given differential equation is an exact differential equation. Okay, now once it is an exact differential equation, we can find its solution just by taking the integration m dx plus integration terms in n not containing x dy equal to constant. Okay, so this will be integration m dx. Okay, so what is m? M is x square minus 4xy plus 2y cube, okay, into dx plus integration terms in n not containing x. So first term does not contain x, so we will take it y cube. Okay, second term contains x, third term also contains x, so only the term will be y cube into dy equal to constant. So finally we can get the solution. Integration of x square with respect to x will be x cube by 3. Integration of 4xy with respect to x will be 4x square by 2 into y, plus integration of 2y cube with respect to x will be 2y cube into x, plus integration of y cube with respect to y will be y to the power 4 upon 4 equal to constant. Okay, and you can see here that will be our final solution. If you want, you can cancel out this 4 by this 2. Okay, so what will be here? 2. Okay, and again you can multiply the given equation by LCM of 3 and 4. LCM of 3 and 4 is 12. Okay, so finally what we will get? We will get this solution. So multiply by 12. Okay, so what we will see? This will be like 4x cube. What is here? 2. So 12 into 2 will be 24 x square y. Okay, this will be 24 xy cube, and this will be 3y to the power 4 equal to constant. Okay, and that is the final solution. Okay, we will see one more example for this, whether this differential equation is exact. If it is exact, we can find the solution. So compare with our standard one, m dx plus n dy equal to 0. So you can see the value for m is x square plus y, value for n is y square plus x. Okay, so find out dabba m by dabba y. Okay, the derivative of x square with respect to y will be 0, and derivative of y with respect to y will be 1. Okay, also dabba n by dabba x. Okay, derivative of y square with respect to x will be 0, derivative of x with respect to x will be 1. So both terms are equal. As they are equal, okay, we can say here as dabba m by dabba y equal to dabba n by dabba x. This implies the given differential equation is what? An exact differential equation. Okay, now once the given differential equation is an exact differential equation, we can find its solution just by finding the integration m dx and integration terms in n not containing x. Okay, dy equal to constant. So put the terms. What is m? M is x square y dx, x square plus y dx, plus terms in n. Okay, first term is y square, does not contain x, so we'll take it, and second term contains x, will not take it. Okay, into dy equal to constant. So finally we will get the integration of x square with respect to x will be x cube by 3, plus integration of y with respect to x will be xy, plus integration of y square with respect to y will be y cube by 3 equal to constant. So multiply by 3 whole equation, what you will see? This will be x cube plus 3xy plus y cube equal to constant. Okay, and this is how we can see, or we can check whether the given differential equation is exact or not. And if it is exact, means if it is satisfying the given condition for exactness, then we can easily find its solution using the given solution. Thank you.